Question number 17, current, electricity. Now what does it say? There's a 6 volt, 2 ohm, 4 volt, 8 ohm, but notice the polarity. They're connected in this way. We got to calculate the potential difference across X and Y. Now essentially it's talking about the terminal potential difference of this cell, if you want to go in that way. Allow me to use the language of cell, the terminal potential difference. Because of the polarity, it's very clear that the current will go in this direction. The resultant driving force will be 2 volt. So 2 volt by 10 ohm, that is 0.2 ampere. That's a current. And the terminal potential difference between them, that's 4 volt plus I, 0.2 multiplied by 8, that much of volt. That would be the case, E plus IR. And 1.6 plus 4, that's 5.6. So where do I have? Option number 3. Let's go to the next one. The next question, question number 18. 2 photons having equal linear momenta have equal wavelength. That is given by statement 1. Statement 2, if the wavelength of photon is decreased, the momentum and the energy will also decrease. Now, as per this, we need to give the correct answer. Now, if the first is true, but second is false, option number 1, and in that way, so many different options are given. So what should we do? The first thing is that we need to verify the validity of each statement, all right? So what is this statement saying? Statement 1, 2 photons having equal linear momenta have equal wavelength. Yes, because if the momentum is same, that means the magnitude as well as the direction, that's same, and the magnitude of the momentum is related to h by lambda. But the reverse is not true. If they have same wavelength, they will not have same momentum. They will have same magnitude of momentum. That's perfectly fine. But as far as statement 1 is concerned, it's correct. What about statement 2? The wavelength of photon, if it's decreased, the momentum and the energy will decrease. No, that's wrong, because energy is equals to hc by lambda. So if lambda decreases, the energy increases. Likewise, if lambda decreases, the momentum increases. While it says that both momentum and energy decrease, that's wrong. So we could come to the conclusion that statement 1 is correct and statement 2 is incorrect, isn't it? So we got to check that option. So if I check it, all right, I'm lucky enough, I could find it in the first option itself. Let's go to question number 19. Now what does that say? Question number 19. Question number 19, okay, 2 stars of masses m and 2m. This is the third time we are getting the question from gravitation. At a distance d, rotate about their common center of mass. All right, so this is the question of, what do you call? We call it as the binary star, isn't it? So here is one mass m and here is another mass 2m, separation between them, that is d, right? That's how it comes. And these two particles, they rotate about their common center of mass. So the center of mass would be somewhere here. And how much would that be? That's an easy calculation, right? You use the expression of center of mass, so that will be 2d by 3. So let's talk about this. Anyway, the time period for both is going to be same. So it doesn't matter which one you take. You may start with any one. That's perfectly fine. Now, how much would be the gravitational force? G m into 2m divided by d square. That is the force. G m1 m2 by r square. And that is equals to m 2 pi by capital T whole square m omega square times the radius. The radius is 2d by 3. Don't forget, the radius of this particle is 2d by 3. So this is all. Little bit of plus minus you need to do, and you would get option number 1 as the correct one. So that was about question number 19. Now let's move to question number 20. What does it say? Oh, right, question number 20, thermodynamics. There's list 1, there's list 2, but it may happen that one may have more than multiple matches. So we need to visualize. First, let's have a glance of the option. I think that would be a better strategy. And luckily, you can see that every single option from one column is having a matching with only one option in the other column. So it's a one-to-one match, right? So let's see, what is it? Isothermal. So that's temperature constant. So A will be having option number 2. Isochoric, volume is constant. Adiabatic, the heat exchange is 0. So the closest one that you find is option number 4. Isobaric, you could see, of course, the pressure is constant. So the matching is 2, 3, 4, 1. Let's search. Where is 2, 3, 4, 1? Yes, option number 3. That was about question number 20. Now, beyond question number 21, it is, numerical based question. You don't have the option in this way. You need to solve it and you need to report the answer. Let's check that out.